Hello, my name is Saber Mesgari. In this presentation, I would like to tell you about the implementation of Soft-Unicast to solve limitations of IPv4, IPv6 for egress traffic and CDN infrastructure. What is Anycast? Well, Anycast, basically you saw a presentation yesterday about the key route. It said that Anycast is used. What is Anycast and what are the advantages over CDN? This is a routing method, through the use of one and the same address. What is the peculiar feature of this? What are the benefits? The client wants to get connected to some address or server. They can get connected to the nearest one without actually knowing that. And this reduces traffic. Key route remains inside the country. And all of these happens because of the Anycast architecture, both at the CDN level or Anycast. Why CDN is used Anycast? This is a question of the load distribution, because wherever I am, my traffic must be able to make it to the nearest CDN. And since the outgoing traffic is going to be distributed fairly, and DDoS attacks, you can come and attack a particular data center or particular server and create some problems. Yeah, the DDoS attacks are distributed. No one knows what they are going to target, so Anycast can address these problems. Here we'll list the advantages of Unicast for the incoming traffic. So you can see we have reduced latency, load balancing happened, improved reliability, improved security, efficient routing, scalable traffic management, and we achieve additional redundancy. This is beneficial from the economic standpoint. Here, there is a question that we talk about advantages of Anycast for ingress and egress traffic, for instance. When the user sends an inquiry via CDN, is there a cache or no cache? And our host goes to the final one. Here we've got egress. And there is the old models that is used in multiple areas. The inquiry comes to the server using IP of Unicast. Send this to the server CDN providers. If you go to their website, if they have /CDN, it will show the list of IP addresses. The list of their IP addresses in different locations globally. Here I can upload their firewall and take a look. As we find a new website, in order to add a new server, we add this list. We expand, we shorten this, and we need to update this all the time. This creates limitations for the distribution CDN provider must constantly update their list. Also specifically relates to the limitations to the outgoing traffic, well, limitations of egress traffic. Well, everyone must have his, its own address. From the standpoint of time, this is really time consuming. When your CDN provider is unable to get it all in the database or get it out of the base, update the list, takes a lot of time. And if this ends quickly, and in this case, many providers have no such function and face problems. Also here, there is a question of exhaustion of addresses. Well, regardless of the fact of having an IPv address, or IPv6 address, this does not resolve the DDoS attack issue. And those who attack, they can see these addresses. They can do DDoS attacks on these servers. On the other hand, those the CDN providers, they can limit their capabilities of doing DDoS attacks because they can be too open. What is Soft-Unicast for the egress traffic? First of all, it was launched. It was an innovative solution that would eliminate gap with any cast. When we talk about any cast, we're talking about ingress traffic. But there is a key concept for the egress or outgoing addresses to allow any cast to address the problems which are related both with to ingress or egress traffic. Coming in favor of upper servers. The main question that emerges here, or the main problem, the egress traffic, that when the inquiry comes, the response to the question is unknown. Well, it's not known where the answer to this question comes back for any cast. Inquiry can come from server A. The response, if it goes back, it can come here, or it may return via server B or D. So in this regard, this methodology is out there, but the problem wasn't really being solved. Basically, the system created a bottleneck. So if we are able to resolve this issue or find some solution, what can we possibly do? So the one range is used, and providers can increase or decrease number of sites. You can manage and redirect traffic. So in this regard, when some problem occurs in a particular region, and basically these problems are resolved by any cast. The problem that emerged together with IPv6 actually gets resolved. There will be no limitations on dynamic routing. We talked about expenditures, about safety, security, reduced cost. The productivity of CDN also improved. How can we actually do this? The unicast implementation technique, when the inquiry gets in from the client, how to get the response back to the client.
Unicast, as you know, uses two methods: IP slicing to choose the target data center. When any Unicast uses 3 data centers. We have 3 of them, and they're all suitable for ingress traffic, kind of inbound traffic. And they use the 24-bit and 24/32 can give a separate address to a separate data center. But it's not announced out kind of outside. It will be this IP will be assigned to this one data center only. And then the second process is the slicing, IP slicing, and it might take a kind of a very long period of time, and some of the counter channels can interrupt this signal. So thanks to port slicing, we can reroute supply traffic to the corresponding service, and also port ranges allow for multiple servers to solve this problem. Thanks to the slicing, that's port slicing. This is what it might look like visually. So when your request returns, we can do routing through the same route by using the IP slicing. What can we use? We can actually use any DSL load balancer to implement Soft-Unicast, or we can use Katran introduced by Meta. Or we can work as a DSR, directed response L4 load balancer. Or generally rely on some high performance and scaling load balancing solutions, like L3 and 4. To further manage the ports, and along with the growth of the infrastructure, our balancer must dynamically assign port ranges to new servers. We also must guarantee scaling up with effective the ports. And routing tables. Routing tables, I mean, we have to divide that between the portals. What are these centralized control plane does? Whenever a request is sent through Unicast, it automatically determines where and what server it needs to be sent, and through which route it needs to go, and return to the higher tier server. In Kazakhstan, for example, they may send it to the server in Uzbekistan, and if the CDN in Uzbekistan, this request will return to Kazakhstan, and it will see that upside comes from Kazakhstan and is kind of sent back or routed back to where it came from, together with the response. Why do we have increased latency? Because these are themselves come to help. They send the packets directly, and after that, the connection happens from the main server. As I mentioned, Katran was designed for low latency packet processing. And the servers, it is essential to ensure that the added complexity of port slicing doesn't negatively impact performance. And ultimately, we have this question that if I have a server number 1 that sends a request to the origin server kind of sends the request back through Unicast to the closest data center, which has the routing table, and DSA determines where the request came from. So the request is processed by the data center, and through port slicing, the request is sent back to the server 1, meaning to where the source came from. on top of CDN, it can be used for other devices. I mean, unicast can be used for the other devices. Benefits of Soft-Unicast with CATRAN. First of all, is IPv4 efficiency. The unicast helps us address the pool exhaustion. Secondly, it is scalability. It supports large-scale deployment by effectively managing IP addresses and port ranges. It gives us high performance, and also it is cost-effective. Well, the configuration. So I would like to show you the steps for implementing Soft-Unicast using CATRAN. Server 1 and server 2 can, through the addresses, and work through the addresses given. Well, I spoke about the benefits, but now about the DDoS attacks. We can mitigate the risk of DDoS attacks and solve the problem of limited resources because we have the dynamic routing that helps us.